Hey, I am Pedro Sodré, the manager of the group Mage, and today I'm going to present to you the Deliverable one. So let's start with the schedule. So here is already filtered with the Deliverable one. So here we have all the tasks that we did. Uh, One comment right here that is we take like a lot of hours compared that we use, but we have 2 weeks with these hours. So we spent like less than 10 hours per member per week. So first of all, the main problem of this is this task, like the mechanical design in 3D. So we have a lot of problems with this mechanical design. So the first problem that we find is the servo motor. The 360-degree servo motor doesn't have precision enough in the degree we want. So we need to adapt it to a 180-degree servo motor. So we need to adapt it. And then we have another problem that we have like the consult the meeting with the mechanical expert with Bruno Bock. We talked to him, everyone in the group, and then he told us that our mechanical structure have some problems, and then we need to make the mechanical structure and design again. So we have like 3 versions of the mechanical design, and yeah, that's because we have like 60 hours, and like in this past few days, every member was spending their time in this. So yeah, another task is determine the measure of all pieces. We have like right here, we measure everything what we need, because it's important to buy these pieces. We have like simple tasks. We also make the electrical design, some studying tasks, some risk response tasks like testing and making the alternate electric design. And yeah, let's talk about the deliverable itself. Just make notes that we are 23 hours delayed because of this problem with the mechanical design. So let's go to the deliverable itself. Just one comment. We also have this journal that we make notes of what we did in each days. Here we talk a little about our problems. You can take a look after this video. So let's go to the deliverable one. That is what is important. So the mechanical project is like this. This is the complete structure. So we divided it originally. Originally, it has 5 modules, but now it has only 4. The container of the candies, the picker, the accept and the reject mechanism, and the base of the project. So let's start with the candy storage. It can storage like up to 4 liters of each type of candy. It has like these holes, and that the candies will go through these holes. We also has these hinges that we will attach the padlock that the owner of the machine, the owner of the machine, will be able to take the candies, like open and replace the candies if necessary. The next part is the picker. So we change this mechanism to a Archimedes screw. So this Archimedes screw will be moved by a DC motor. This is one of the changes that the mechanical expert that advised to us to do. So the candies will fall out through this hole. Through this hole right here. And then with their Archimedes screw, they will move to the next part, to the next section of the machine. So you can see like the top view of this. We can see the motors right here, and then the Archimedes screw that will move the candies through this hole to the accept and reject mechanism. So move to the next mechanism. The candies will fall from this to these scoops that we made like triangular ones, because we will use the servo motors for this right here. Like we have these two servo motors. Depending of the customer, if he accepts, it will turn into one direction, into clockwise, for example. And if he rejects, the servo motors will move counterclockwise, for example. So we can see this moving. And the final part, we have this base. So in this base is where all the hardware, all the components will be allocated. Also, we have this ramp where the candies will be fall and go to the customer. So this will turn into a direction like clockwise, and then the candies will fall out into this structure. We made this like triangular because the servo motor, when it moves like 90 degrees, this part of this mechanism will be in 45 degrees. So we will be pretty sure that all the candies will be dropped. We can see the top view of this right here. So if this move like in this direction, it will fall out and the customer will take the candies. If this moves to the other direction, it will fall out into these boxes where the rejected candies will be stored. We can see like in this image, like this the vision from the top. Here we can see like the power strip that we will use. I will explain more in the electric part. The power source, the PCB, and the Raspberry. So here we can see this mechanism more clearly. So if this moves this way, it will fall out in this part of the structure, and then it will fall out to the customer. If he turn in the other way, it will fall out into these boxes. Right here in the front, we have the camera that is in purple right here, and this is the place for the display. This part here in the in the back is where we will move the wiring of the structure to the camera and to the display, to not like have contact with the candies. For the final part, to the base 2, this is in the back of the base. So we have like these hinges that is in yellow that we will use to move this door, and this in red is where we will like put a padlock to lock and protect the candies that will be rejected. So the owner can have the key for the padlock and then collect the candies, and also he can like turn on or turn off the structure with the power strip. So let's go to the electric project. Right here we have like the wall socket where our power strip will be connected. In the socket one, we will use the Raspberry source. We are doing this because we don't want the Raspberry to be burned. So that's why we use the Raspberry source that comes with the Raspberry. That's why we are not using the computer source to power the Rasp. So in the socket 2 will be the computer source that has the 12 volt source and the 5 volt source. The 12 is for 2 step downs that will power the 2 servers. We are using the step downs to 7 because we want the higher strength for these servo motors, and we are like powering the servos with higher voltage because to have higher torque and higher strength. And with this 12 source, we will move the 2DC motors that will move the Archimedes screw that is in the second module, in the second part of the mechanical structure. And the 5 source we will use to power the display of this. This part is like is a risk response task that we will use if is necessary to use like a second microcontroller. In that case, we will use the Raspberry Pi Pico for feeding this, for controlling the servos and the DC motors. So this is the electronic project where all the wires is connected. I will take part from part, so don't worry. You can see like they all in this. In this first part, that is the servo part, that is this part right here. So we have the 2 servos connected to this step down, and then the power sources that will power the step down, that will power the servo. And this is the connections with the Raspberry that we will see right after here. So the servos is right here in these pins. We have this connector from the power source of the PC. That is it. We need to do this to power, to turn on the power source, that we can use like all the pins. Here we have the connections with the display and in the Raspberry 2. So all the connections in display. We have like these connections too, that is right here, and that's it. These two connections is the DC motors that we'll see right after here. So this is the connections with the DC motors. We have some diodes, some resistors, and some transistors to control the motor. And all of this will be in the PCB, in the printed circuit board. Yeah, and that connections with the motor, powered with the 12 power source, 12 volts power source. You can see right here the project of the PCB. Here we can see the components. For example, the resistors, the diodes, the connectors, the servos, and all other components right here. We can see like the routing of the PCB right here too. That you can see like how the PCB connection will be look like. Right here we have the connection with the plan B part. That is that if we will use like a second microcontroller that is Raspberry Pi Pico that will be connected to the Raspberry and will control the servos and the motors, and also the routing of this thing. And that's it. Thank you.